Stray currents back on track. This is Frank. Frank works for a mass transit network that operates urban trains on DC lines. Frank is responsible for maintaining the traction power supply system and the infrastructure. Part of his job is to observe stray currents. Stray currents are unwanted and, in fact, shouldn't arise. In the ideal case scenario, the traction current flows from the substation through the overhead contact line to the train and back to the substation again on the track. This circuit is isolated from the earth potential. That would be the ideal case. Unfortunately, isolation between the rail potential and the earth potential in reality is never ideal. A part of the traction current therefore flows back to the substation as a stray current via the earth. The return flow takes place mainly over metal structures, for example, gas pipes, water pipes, pole foundations, or bridges. Stray currents are not an immediate danger for people or for the operation of the railway system. However, on a long-term basis, stray currents cause heavy corrosions that weaken metal constructions where the currents exit. As a further consequence, pipes become leaky, retainers could break, and also entire bridges could become unstable. All this leads to hazards and high costs. Frank's job, therefore, is to monitor the stray currents. Currently, this is ensured by repeated measuring. A colleague measures the rail potential opposite to the earth potential. Based on the results, he identifies unintentional changes, which indicates the stray current concentration by insulation faults. Frank's maintenance team supports him in the work. The tasks are extensive. It often takes several teams to carry out the necessary repeated measurements. His co-workers must regularly carry out the work in all locations. To do that, it needs reliable planning and coordination. Also, because nightly operation pauses are necessary to do the measurements, the consequences of the numerous operations, a lot of man-hours, and high costs. The documentation of these results measured manually involves a great effort for Frank as well. He must also do the evaluations and analyses by hand. Over the years, the costs add up. Something else that bothers Frank is that his stray current observations are permanently repeating individual measurements at extended intervals of time. He would prefer continuous independent measurements and documentation at the push of a button. Frank's solution is called Sitras SMS. It helps him work more efficiently. Frank decides to invest in the system. Whenever he wants to know what the stray current situation is, he can find out promptly with a few clicks. Sitras SMS records, analyzes, and informs constantly on the basis of the most current values. Problems are shown immediately. The system also shows problem areas, giving Frank's team pointers for the error search. Frank is happy. He can make a stray current diagnosis at any time, and effort is minimized. He and his team are able to concentrate on other tasks now. Management appreciates the increased efficiency. By introducing continuous monitoring of stray currents, Frank has, completely in the spirit of minimizing risk, done the best thing possible to prevent possible damages and hazards in the future. The damage can be enormous. Don't let it come to this. Sitras SMS. Stray current monitoring system.